Today, our topic is energy limits to our industrial civilization. And I want to welcome my very special guest, Richard Heinberg. He's a senior fellow with the Post-Carbon Institute, and he's regarded as one of the world's foremost advocates for shifting away from our current reliance on fossil fuels. He's the author of 14 books, including seminal works on society's current energy and environmental sustainability crises, peak oil, peak everything, and the party's over. Those are early books from the early 2000s that I remember. And he's written hundreds of articles that have been published and republished widely. He and his wife, Janet, live in a permaculture home here in Sonoma County. Welcome to Ecologic, Richard Hein.
Hey, Bernie, it's good to be with you.
I mentioned that you were in the early 2000s already writing books about peak oil. What brought you to this subject in the first place?
Well, it really started in the early 1970s when I was reading books like Limits to Growth and Small is Beautiful and so on. I was realizing very early in my young adulthood that our current industrial way of life is fundamentally unsustainable. And that was a huge wake-up moment for me. And I've basically spent the rest of my career trying to figure out how is it unsustainable? What are we doing wrong? What are the consequences likely to be? And what should we do about it? And that's led me into all sorts of different nooks and crannies of self-education and exploration. But it was in the late 1990s when I happened onto the work of a couple of petroleum geologists who had spent their careers as exploration geologists and knew the whole industrial process of extracting oil and turning it into useful commodities about as much as anybody on the planet. They believed that world conventional oil was very close to its maximum rate of extraction. And that led me then to start looking at oil, why is that important? Obviously, it's an energy source. Why is energy important? What are the alternatives? Where do we go from here? That was the basis of pretty much all of my books starting around 2003 until the mid-2010s.
Obviously, you discovered Hubbert. He's the fellow credited with raising peak oil.
King Hubbert. King Hubbert was active in the 1940s and 50s. He lived past that time, but his main contributions were in the 1950s with a series of papers in which he suggested that U.S. oil production was very close to its all-time peak. In fact, it did start to decline around 1970 and declined very dramatically and rapidly after that year. And he said this same thing is going to happen for the world as a whole. The problem isn't when are we going to run out of oil. It almost never happens with any natural commodity. What does happen is as we extract more and more and get used to using more, demand increases because it's useful stuff. And then it gets harder to get the next increment of oil or natural gas or coal or silver or gold. It gets harder to get that next increment of the stuff out of the ground. It costs more money, it costs more manpower, it costs more energy.
You taught me that term, energy return on energy investment. It made so much sense. We come to a point of, well, there's no more business opportunity. It's over. It isn't like we've run out of it. We've run out of the ability to extract it in a way that you can get financing.
This is particularly relevant when we talk about global coal supplies, because a lot of times people say, there's massive amounts of coal out there. And yeah, there's still a lot of coal that hasn't been mined. A lot of countries have counted coal that it's in the ground, but it would take too much effort to get it out. It would cost too much to extract it, like there's coal under seabeds, for example. And maybe somebody could develop the technology to get that out, but it's going to be very sophisticated technology, very expensive. We don't have it now. Counting that coal as reserves is really kind of a fiction. Global oil discoveries have been declining since the 1970s. Every year we discover maybe 1 new barrel of oil for every 10 barrels that's consumed. Obviously, that can't go on forever. We're living off the legacy of exploration that took place in the 1930s, 40s, and 50s right now.
I remember as a child my parents telling me the ocean was infinite and whatever you put in there would get cleaned up. But as I got older, I realized that was a lie. That was a fantasy. There's a lot of our society that acts like fossil fuels are still out there. We're still going to get them. In fact, we'll even invade other countries if we have to, but we're going to keep the oil flowing because that's what we know, that's what is. And so when you wrote The Party's Over, not everybody heard that or believed it, and they might say, Richard, were you wrong? Because people are still partying.
Yeah, well, I was partly wrong. The folks I was listening to were saying that world oil production would likely peak in the first decade of this century, sometime around 2005. If you read them closely, what they were talking about was conventional petroleum, the kind of stuff that we relied on throughout the late 19th and 20th century. Actually, that did happen. Global conventional oil production flatlined starting around 2005. But what happened after that, some new technology enabled the extraction of lower quality oil deposits that exploration geologists have put aside, believing that it would be too difficult and expensive. Different kinds of resources, including the Canadian tar sands, the extra heavy oil of Venezuela, and also what's in the business called light tight oil, which is produced by hydrofracking and horizontal drilling. That's come on strong here in the U.S. The U.S. had been declining dramatically since the 1970s in oil production, and starting around 2010, U.S. oil production shot up in a way that we've never seen before in any country in modern history. Today, the U.S. is once again the world's foremost oil-producing country, and it looks like the problem of peak oil has been totally solved. The problem is the nature of the resource itself. Light tight oil, as the name suggests, bonded in very low permeability rocks, often shale, and to get the oil out of the ground, companies use explosives. They drill horizontally through the shale. They try to get as much contact as possible between the wellbore and the layer of shale that has this light, tight oil in it. And the result is they get a lot of oil out of the ground very quickly from each well, but then each well depletes very rapidly compared to conventional oil wells. So that means they have to drill a lot of wells.
I'm sorry to interrupt, but I think people like to know, what does a conventional oil well duration look like? You know, how many years is it productive typically?
Well, it depends, but often, 10, 20, 30 years or perhaps even longer. Typically with a tight oil well, 60% of total eventual production will happen within the first 2 years. And then it'll trail off pretty rapidly after that. So yes, there are fracked wells that were drilled back in the early 2010s that are still producing, but at a very low rate. They had to drill hundreds of thousands of wells over the last 15 years in order to make this happen. This is true in the natural gas world, too. The U.S. has become the world's foremost natural gas producer after seeing declines in natural gas production. And again, it's due to this new technology of fracking. The wells deplete very rapidly, and they have to be drilled in order to keep production steady, much less increasing.
Why can't we believe that our ingenuity, this new technology we keep discovering, won't come along and squeeze even more out of the planet?
Right. Well, we get back to what you brought up earlier, the energy return on energy invested. Technology seems to be magic often, but it's still physics. And if it costs energy to get energy, then that equation of how much it costs is what's most important. fracked oil, fracked natural gas require high prices, high gas and oil prices in order to work. Right now, with oil at $60 a barrel, folks in the fracking industry are chewing their fingernails because they're really not making much profit. They want to stay in business. They're hoping the price of oil goes up. 20, 30 years ago, $60 a barrel oil was expensive. Now, not so much. We've gotten used to a different regime. This isn't just the view of oil and gas pessimists. The U.S. Department of Energy, even in the Trump administration, which is bullish on fossil fuels, is now saying that U.S. tight oil production is set to start declining this year, 2026. And U.S. shale gas production will start declining before 2030.
I'm not hearing that on mainstream media.
Yeah, depletion is not a word you ever hear in mainstream media. It's just never discussed. And yet, if you're in the business of extracting stuff out of the ground, depletion is happening all the time, and it constrains what you can do now and in the future. Depletion is a fact of life for modern industrial civilization, and it's one that we have banished from our thoughts. It has not just to do with fossil fuels, but also with the minerals we use to make alternative energy sources, including uranium and all the minerals we use to make solar panels and wind turbines.
We've got to a point of understanding, even in the Trump administration, that fossil fuels will go away. We got to go to something else. Now, there's been this belief that all we have to do is tap into the sun. That's unlimited energy. We can tap into wind and tides, and there are all ways we can get renewable energy and continue living the way we're living. What do you say to that?
Oh, that's a big discussion. I co-wrote a book on this subject, Our Renewable Future, with David Fridley, who's probably the best energy expert I know. He was on the energy analysis team at Lawrence Berkeley National Lab. And what we did was imagine what would it take to get all of our energy from renewable sources. And we took a year to do analysis, kind of our focus group of two going back and forth, me asking questions and David doing analysis. What we came up with is a lot of things are possible in principle. It's possible in principle to run airliners on hydrogen and make the hydrogen from solar panels, from water, using electricity from solar panels. You could go on and on. All the ways we use fossil fuels now and the alternative technologies that we could replace them with. And some of those are happening, like electric cars. I drove here to the recording station in my handy-dandy electric car. It works great. Much prefer it to fossil fuel cars that I've owned in the past. That said, I think few of us realize how huge a challenge it actually is. We're talking about electrifying most of industrial society. Solar panels and wind turbines produce electricity, which is great. Electricity is a very versatile energy carrier. However, our current energy system is only about 20% electricity. Ooh, okay. And the other 80%, we use fossil fuels directly for heating, for industrial processes, for transportation, and all sorts of things. Replacing that 80% of our current energy usage that is done with fossil fuels directly, that's going to be by far the biggest industrial project in all of human history. It dwarfs anything even remotely comparable. And it's going to be extremely expensive, and it's going to require a lot of energy. Almost all of it's going to come from fossil fuels.
Yeah, like we were talking about, fracking extended the lifetime of an oil well. This is a way to extend the lifestyle we've been living based on fossil fuels by having fossil fuel extenders, I'll call these renewable resources, because none of them come without fossil fuels. I can't imagine that a wind farm is going to grow all that's needed to do the mining and manufacturing of the next baby wind farm. And that doesn't even count the ecological destruction that's happening in a wind farm or in a solar farm. People are fantasizing that we can swap out the supply, because what's the alternative? Reducing our demand. instead of you driving here with your electric car or me driving here with my hybrid car, we could be biking or walking.
Well, when David and I did the analysis on the energy transition from fossil fuels to renewables, we found it was almost impossible to make that transition work without a substantial reduction in overall energy usage. And when I say substantial, I'm talking about 70 to 90% reduction in overall energy usage of society. If we did that, then the replacement of fossil fuels with renewables becomes feasible. But without that reduction in overall energy usage, not so much. Now, here we are in 2026, and what's actually happening? We're seeing a dramatic increase in demand for electricity, not for making solar panels, not for electrifying all the things we do with fossil fuels, but for data centers, for AI. This is throwing a huge monkey wrench in the gears of a process that was already enormously challenged from the get-go.
Our society is not dealing with that reality. Most scientists would say that we have to reduce our demand. But we've been reducing our demand in really tiny ways. We can ban straws in restaurants, but not in fast food. We can ban the use of plastic bags if they're single use. But we can't bring ourselves to ban all plastic, to stop all drilling, to say goodbye to industrial civilization because we are fully engulfed in it.
You could say it's partly human nature. Nobody wants to give stuff up. But it's also systemic. Our current economic system, including schools of economics, the economic theories that are taught in those schools, our economic system in terms of how investment works and the expectation of returns on investments, how the stock market works. All these things grew up during this totally anomalous period of the last century and a half when the economy was growing relentlessly because we had more energy. That energy is the economy. Without energy, nothing happens.
And energy enables complexity, and our industrial civilization is becoming ever more complex, and we know that all complex civilizations eventually collapse. We know that this is an exponential curve. It's hard to get off this roller coaster.
Right. As I was saying, we have all these assumptions about how things should work that are just based in our own experience. We've all grown up during this anomalous period of time of rapid economic growth. Before fossil fuels, 70 to 90% of the population in most countries worked at farming, because that's how many people it took on the land to produce enough surplus so that other 10 or 20% of the population could live in cities and be doctors or accountants or kings or whatever they were. Less than 1% of the population can work full-time at farming and produce enough food surplus. Why is that? Because we have tractors, combines, all these giant machines running on fossil fuels that can produce that kind of surplus. Plus, we have agricultural chemicals made from fossil fuels, pesticides, herbicides, fertilizers, etc. What happened as a result of this immense switch in food production was that most of the population was freed up to move away from the farms into cities. During the 20th century, the biggest demographic trend was urbanization. When people move to the cities, they're looking for manufacturing jobs. We can manufacture a lot of stuff now because we have all this energy, and we can put people to work full-time as inventors to invent new technologies to manufacture. This is how economic growth worked and how we became deluded to think it was perfectly normal and natural and could go on forever. But the thing is, we live on a finite planet. Nothing grows forever on a finite planet. This was the insight of the Limits to Growth study that came out in 1972, which foresaw the situation that we're in right now in the early to mid 21st century.
One of the things that has been left out of our economics is the cost to the environment. We've monetized most everything, but a tree, it's Lumber is valued by how much can be cut, but not the opportunity cost in terms of providing habitat for other species and health for our ecosystem and watershed.
In a society that's growing fast, the tendency is to have a very short time frame for understanding where you are in the universe, what the past is and what the future is. Societies that have been in one place for a long time and bumped up against environmental limits many times, we call them indigenous societies.
Yes.
Those societies learn how to live within limits sustainably and have a long time horizon. They make their decisions for the seventh generation in the future. We're making our decisions for the next quarterly profit. That kind of short-termism is coming back to bite us.
I think there is a movement recognizing the sustainable examples that indigenous cultures have shown through millennia, but also in the current where they're still existing. Unfortunately, the colonialism of our industrial civilization has wiped out a lot of the indigenous cultures. Evolution, in order for our human species to continue, requires diversity. That was always there when people lived with the other species. I think indigenous means of the land. We are now so smart and can have technologies that can take over other areas, deplete their resources, and use them for our benefit. So that whole model is what we are left with today. But I think you would agree that we are at the end of that model. Industrial civilization will collapse. It's just a question of when, how it unravels, and what it looks like in the process.
Collapse is a scary word. For a lot of folks, once they hear it, they stop thinking. It's like, okay, collapse, end of story. Everything falls apart instantly, and that's it. Societies have been collapsing for tens of thousands of years.
And we've had economic collapses that some people say is, well, I might as well kill myself because all my money was tied up in that stock market or whatever that just went to zero. And they think their life is over. Well, just because that way of life, that way of providing for ourselves in the industrial ways collapses, doesn't mean we as people have to collapse, because we can adjust our demands. The homes we have, we don't need the food from around the world. We do need to eat. We do need health. We do need shelter. We do need basics. I admire some young people who purposely go find a place to live off the grid and try to live by becoming self-sufficient. Very hard to do. And I remember when I was younger, groups of people were motivated to do that, do these communes, but they always collapsed because there weren't enough people.
There's a lot to learn from the communitarian movement, and we will undoubtedly experience a simplification of society. A lot of things that we take for granted now will be falling away, and we will relearn how to do a lot of things our ancestors knew how to do, and we will live in different kinds of social arrangements. One of the most exciting ways of rethinking and re-understanding sociality is the notion of bioregionalism. Organizing ourselves according to our bioregions rather than the kinds of arbitrary political boundaries that we're so used to in the modern world. It's how people lived up until the modern industrial period.
I call that living local.
It's living locally and living in a way that's appropriate to the ecosystems that you're actually depending on.
Richard, we think that we can use less energy by becoming more energy efficient. So we get more miles per gallon on our car, and we get more miles per kilowatt on our batteries. There's a fellow named Jevons that thought about that a long time ago. What would he say about our belief that by becoming ever more efficient, we can still have what we have now and use less energy?
Yeah. Stanley Jevons was an economist in the mid-19th century, a British economist, and his area of study was coal. In the mid-19th century, Britain ran on coal, and it was the biggest coal economy in the world. What he was seeing was that as coal was produced more efficiently, what that resulted in was higher rates of extraction of coal and therefore faster depletion. So he saw that there was a paradox there. Rather than efficiency resulting in conservation, efficiency was actually resulting in higher rates of extraction and use. We see the same basic pattern from Jevons' time up to the present. We've just gone through this big transition in the last 20 years from incandescent light bulbs to compact fluorescence and now LEDs. And LEDs are much, much more energy efficient than incandescent lights. So are we saving this vast amount of money on lighting? Well, not exactly, because what we're doing instead is we're lighting so much more stuff. We've put LEDs everywhere. You look at any piece of equipment in your house, it's got an LED light on it. Even an extension cord, you want to plug it into the wall so you can plug other stuff into it. It's got its own little LED. Yes, there are some energy savings from LEDs, but the Jevons paradox is eating away at that.
Experienced that for myself. I had a truck, a Honda Ridgeline that I loved, but I was getting 20 miles to the gallon. I was thinking, well, I need to get something more energy efficient, so I got a Kia Niro. It was a good little car, getting 50 miles to the gallon. Guess what? I drove more miles. Yeah. It's like, oh, yeah, I'm getting this really cheap now. Yes, the price went up, but my miles per gallon is so much better. But those tires on the road, they're getting down to a point where I may have to put new tires on. There's the idea that when I'm on the road, I'm requiring another lane on Highway 101 to be built. Take this infrastructure for the car for granted, and I only think in terms of I still can live a life that is car distance away in an hour or something like that.
Efficiency is still important. We need to make our stuff more efficient, but it's not a complete solution to the problem.
It fools us. It lulls us into the idea that technology will save us. I find that pernicious.
There's another kind of efficiency that is pernicious, and that's what's called economic efficiency. Ask any economist if you can grow corn cheaper in Iowa than any place else, what should you do about that? Well, obviously, grow more corn in Iowa, grow all of your corn in Iowa, maybe. And why bother growing anything else in Iowa except corn? Because that's the most economically efficient way to do it. And we've organized our whole economy that way. That's what globalization is all about. But what results from that is an extremely fragile system. If the corn crop fails in Iowa, then nobody's got corn and Iowa has nothing. So that's the problem that we're setting ourselves up for with more and more economic efficiency. Instead, we should be looking at relocalization and community resilience. And those things require redundancy,
yes,
which is just the opposite of economic efficiency. Maybe you pay more for some things. It's inconvenient. Maybe you have to do without in some cases, but you're building up the resilience of your community, which is what you really rely on in the final analysis.
Yeah, it's a matter of priorities. If your priority is to accumulate more wealth in your lifetime, that's one priority. To make sure that future generations of humans have a future, that's a different priority. And that's the priority that I, as a grandpa, I'm sure have. Sometimes it gets trumped by the immediacy of what it's doing to me economically in the short term. And we've talked about that there's almost certainty that eventually this collapse will happen. How, we're not going to speculate, and when is hard to anticipate. But that it'll happen, and the idea that we shift our priorities to thinking longer term, to think about future generations, and allow for some inefficiency that comes from the redundancy. That is so vital in evolution, because if we want to shortcut to human extinction, stay with the industrial model because putting all your eggs in one basket, you're subjecting all the other species, including all the other humans on the planet, to what you're bringing yourself down with. If you want to preserve a future for our species, which I put as the highest order of business, you need a new economics. You need an economics that is not just about money and everything that's monetized in our system, but is really on the less number of extinctions of other species that are happening, what's happening to endangered populations in terms of numbers and them going up. When we had a flood in Sonoma County, I was thinking about how we view flooding as a hazard. So we get flood insurance. It's a negative because it impinges upon our home and cost. These are natural hazards. But we don't see the other side to it. The flooding that happens in the Santa Rosa Plain brings nutrients that wash over the watershed. Earlier settlers didn't see the value of that. They thought in terms of marshland, wetlands, get in the way, let's fill them in, let's not have flooding, let's channel Santa Rosa Creek to go in a straight line. But then complain that flooding has happened. We are not seeing the benefits of that natural system at work. I see a little hope, like the Klamath River just celebrated the last hydroelectric dam being taken down. We have one river, the Smith River, that is undammed in California. We have huge projects to move dam water throughout California, but to give up on that system and rely instead on the local watershed where you make sure that it's as clean as possible because you're drinking from it, you're carrying water from it, or you're diverting from it for your crops. We haven't made that shift, and it's because we don't know enough about honoring the watershed that we live in, the ecosystem that's here.
What we're actually seeing right now is, with regard to climate change, the world has taken climate change as an enormous threat and challenge. And of course, we know that there have been annual meetings of the IPCC to address this, and nations have made targets of reducing emissions and so on. What's actually happening is that emissions are still growing, even though solar and wind electricity production has been growing very rapidly. Solar's been getting much cheaper. There's a lot of good news, but at the end of the day, the climate only cares about whether emissions are going up or going down. And so far, emissions are going up. And why is that? It's because of the insistence on economic growth. The economy is growing 3.5% per year, the global economy. That means we're using the equivalent amount of increased energy. And only part of that is coming from rapid increases in electricity from solar and wind. And then, of course, 80% of energy usage is direct fossil fuel use. That's increasing too. This is the fundamental problem, because we want to maintain economic growth while we make this energy transition. But the manufacturing of all of the new electric and renewable technologies is going to take energy. Most of that's going to come from fossil fuels. So we have increased carbon emissions baked into that scenario. The only way to avoid that is to reduce energy usage. What does that look like? We've seen that in history on a few occasions. For example, the 2008 financial crisis, the COVID pandemic of just a few years ago, the Great Depression. These were instances where global carbon emissions declined. If you're in favor of having a stable climate, you're also, in effect, in favor of having economic recessions or depressions. Now, politicians don't want to talk about this. People in the energy world don't want to talk about it because it's so gloomy. Okay, we don't want to have climate change. That's the end of the world. Imagining coastal cities being drowned and so on. But What's the alternative? Everybody wants to think the alternative is continuing to live exactly the way we are now, only with solar panels instead of gas stations. And it's not that simple. We need to figure out how to have a long recession, simplifying and reducing the scale of the economy without the human cost of people being thrown out of jobs, going hungry, and all of the things that happen when we have an economic depression.
Our economic system and our political system are so baked into this fossil fuel industrial civilization that it can't really maneuver out of it, and we don't want to get out of it.
There are discussions around the fringes about degrowth, and especially in Europe, there's a pretty big degrowth movement. Donut economics. Kate Raworth, a European economist, has written a brilliant book about how we could make a more circular economy that would, instead of having growth as its main goal, a good life. Why do we always aim for economic growth instead of aiming to meet human needs, not just for stuff, but also for happiness and connection with other people in our communities? If we oriented our economic system around those goals, then even as we have less energy throughput, less economic throughput, we could actually enjoy ourselves more. How happy are people right now in our current situation?
I remember when Europe was ahead of us in wanting to put taxes on fossil fuels. France invested heavily in nuclear energy. And over time, they've recognized that nothing compares to fossil fuels. And the economics we have and the political systems we have, they can't get us out of this box. So I fear and believe that we're not going to solve this problem. We're going to have to let go of industrial civilization as it collapses and accept it mentally and move forward to more indigenous living, more bioregional living, more local living, more simple living.
The bioregional vision is, you could call it a long-term goal. That's the North Star. That's what to have in mind as we make all the decisions that we will be making over the next 2, 3, 4 decades. Industrial civilization isn't going to go away all at once. If it did, billions of people would die very shortly.
Yeah.
It's going to be a process of simplification, of relocalization, of more and more lengthy economic recessions until we get to a point where we are living within Earth's limits. That's a long ways away at this point.
But I think it's worth holding a priority for that, to getting there sooner rather than later, because I think we're on the verge of actually threatening mass extinction.
Right.
And to me, that's such a horrendous outcome from this species having been evolved with so much intelligence and not using it correctly to the purpose of maintaining our species. Now, you mentioned population. I'm understanding from experts that 8 billion is too many, and maybe 1 billion is more like it. So losing 7 billion needs to be in our thinking, not that we want people to die, but we also have a lot of investment these days in longevity. Both my parents died in their 50s. I'm already 77, and when I got to 60, I thought I was an extra life. We extend life over and over again with medical technology, but is that really in our future?
Right. The world is certainly overpopulated with 8.3 billion human beings right now. A few courageous people have been pointing that out for a long time, but that subject has gotten radioactive. Meanwhile, something has been happening inside the statistics. The trend has shifted to the point where fertility is declining in most countries around the world. And the global population is going to peak much sooner than projections were saying, even just 10 or 20 years ago. Now, that's a good thing, but why is population peaking? Some of it is mysterious. Some of it can be ascribed to, well, as people get richer, it gets more expensive to have another child because you want to send them to good schools and so on. So the demographic transition, which demographers have been talking about for decades, is a real thing. And as nations get wealthier, families tend to get smaller. younger people are looking at the world situation and they're saying, is this a world that I want to bring a lot of children into? And another thing that's going on is that we're flooding the world with toxic chemicals, including hormone-mimicking chemicals that are causing male sperm counts to decline rapidly. And that's one of the reasons that we're seeing declines in insect populations, bird populations, and so on. But now it's hitting human beings as well. I work for a nonprofit think tank called Post-Carbon Institute, and resilience.org is our public website that's updated every day with fabulous articles and essays from people around the world who are thinking about these issues we've been talking about for the hour. And then I also have a personal website, richardheinberg.com, that has an archive of hundreds of articles I've written, links to my books.
With a lot of good information about books and people researching in different areas. Listeners, I thank you for listening, and I hope you enjoyed the program. Take advantage of checking out some of those sites that Richard's talking about, because there's a wealth of good information there,